triangles look gnarly, right? Because there's some fractions, but it's not bad. Okay, a sphere is the set of all points in space that are equidistant from a given point called the center. Nope. Okay, so the equator is actually like a diameter. It's what we call a great circle. It's any line around the circle that's going to chop your circle in half. Not circle, I'm saying sphere. I want sphere. Okay. All right, what is the segment that has one endpoint at our center and the other endpoint on our sphere? Radius. It's a radius. It's an okay. What about a segment that passes through the center with both endpoints on the sphere? Diameter. Oh, okay. Sorry guys, my board is doing that thing where it like will delete a letter that I wrote and then put it back on later just to mess with me. Okay. Oh, I thought I paused it, but I didn't. The video got all that. Okay, awesome. So you can see where those are labeled. Okay. The surface area of a sphere is 4 times the product of pi and the square of the radius of the sphere. So 4 pi r squared. Do you guys remember how in the video they took the 4 circles, okay, and they unwrapped them into the triangles, okay? So they unwrapped them into the 4 triangles that went like this, right? And then the top was, what was it, 2 pi r, and then this other side was 2 pi. No, 2r. Thank you. I was like, that's not right. 2r. Okay, and then we get the surface area for a sphere. Okay, questions? All right. Cool. People at home might be wondering how we turned a circle into a triangle. So if you can imagine starting with the radius as like this part of the triangle and then slicing, oh my gosh. Slice, how does it work?
That's scary. Maybe.
Okay, let me think about it. We'll come back to it because right now my brain just gave up. I might have to watch the video again. Okay. The volume of a sphere is going to be 4/3 the product of pi and the cube of the radius of the sphere. Okay, that video was even harder for me to... No, that one wasn't too bad. That one was the one where we did the water with the cones again, and it took 2 of our cones to fill up 1 sphere. Okay. That one was actually better. So using these formulas is pretty easy because they both have, even though one of them has some crazy fractions in it, they both only have 1 term, so you don't have to worry about the lateral area and the base. You just have to worry about the 1 surface area because the sphere doesn't have a base. Facts. Okay, so we're going to find the surface area and volume of the sphere. We're going to leave answers in terms of pi, so these are going to be exact. Okay, so let's start with the surface area. So what is the formula for the surface area of a sphere? 4 pi r squared. Okay, so we're just going to plug in the stuff we know. What's the radius?
7.
Good. That's basically all we have to plug in. Isn't this great already? So don't forget to square the 7. What's 4 times 49?
196.
196. So we got 196 with the pi. These are centimeters to what power? Squared, because this is the 2-dimensional wrapping of the 3-dimensional figure. Okay, volume.
4/3 pi r cubed.
Okay, again, all we have to do is plug in the r. Thank you, spheres. What is 7 cubed?
323.
Okay, times 4 divided by 3.
455.3.
Oh, okay, so we're going to have to, can we have that as a fraction? So can you do math, enter, enter?
1,372 divided by 3.
Okay, 1, 7,
1372.
divided by,
3.
okay. Centimeters cubed.
Okay, wait, how did you make it into a fraction?
Well, okay. Here's the thing. We cubed the 7. We multiplied by 4. Now, if you're thinking about the way that numbers work, okay, do 7 and 3 have any common factors other than 1? So am I going to evenly be able to divide 3 into something that's like 7 times 7 times 7 and doesn't have a 3 that's being multiplied into it?
So you just
No.
kind of
Same thing with the 4. Are there any factors of 3 that are also factors of 4 other than 1? Okay, so we got this crazy decimal, but I'm thinking there's no 3's in that numerator because we didn't multiply by a 3. We didn't have a 3 as a factor in any of our starting numbers. So it's probably just going to be a fraction that doesn't simplify. Does that make sense to everybody?
that actually does.
Okay, perfect. Then I'm glad I recorded it. All right, any questions about how to do this? Now, if we had cubed a 12 or like a 9, we'd be able to divide away a 3, right? Okay.
Oh, this is the last page.
Last page, short and sweet. All right, we got to find the surface area and volume of the sphere. Okay, this one just has rounding in it. Do we need to do this one? Okay. We're going to skip to number 3. The volume of the sphere is 36 pi inches cubed. We're going to find its exact surface area and then also round that to the nearest tenth. So this is one of your favorites where you get to work backwards. So looking at both of our formulas, what is the one thing that we need to use both formulas?
Radius?
The radius, okay, right? They both depend on the radius of the circle, right? Because the circumference is linearly dependent on the radius. The circumference is just a multiple of the radius, right? Everything depends on how long the radius is. Everybody okay with that?
Yeah.
So this is one of the fun ones where we get to work backwards, get the radius, and then use the radius in the other formula.
Square root by 3.
So let's start with what we know. They're giving us the volume, so let's start with the volume formula. Volume equals 4/3 pi r cubed. Okay, let's plug in what we know. What is the only thing we know?
Volume.
The volume. So we're going to take this volume, plug it in for that V. So I have 36 pi equals 4/3 pi r cubed. Okay, what's going to happen to my pi's?
Cancel.
Bye. Okay, how can I undo dividing by 3 and undo multiplying by 4 at the same time?
Multiply by the reciprocal.
The reciprocal. Ding, 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 ding. So I'm multiplying both sides by 3/4. Now, I happen to know that 4 goes evenly into 36. 9 times. So what's 9 times 3?
27.
Ooh.
Now, if I square a negative number or a positive number, I get a positive number, right?
Yeah.
Okay, what happens if I cube a negative number?
So it would be positive. No, it would be negative.
Because it'll be a negative times a negative times a negative. So the two negatives pair up and make a positive, but then we have the one oddball, the third negative, that turns it back negative again, right? So whenever you do the square root, you have to watch out for the two signs, the positive and the negative, right? Okay, but when you're doing cube root, you get to just keep the sign and not worry about it. Okay, yes. All right, so what is R?
3.
3.
That's kind of a nice, pretty formula.
Yeah, that's what I'm saying. Okay, so we're going to use now the surface area formula.
Pi r squared.
I heard someone say, wait, do we need to go back? Okay, so we found the radius. We're just going to plug it in. All right, 3 squared is 9. 9 times 4 is 36.
Oh, I think we're finding both. Does it say both? It's exact and then.
And then-
Yes, and then we will round. 36 pi inches what?
Squared.
Squared. So that is approximately
It'll be 113.
113.1.
Yeah.
113.1 inches squared. Okay, that was fun.
Well, these circles are pretty nice.
Yeah, I'm telling you. All right. Okay, we have a spherical basketball placed inside of a cylinder. Okay, the diameter of the ball is 10 inches. Do you guys remember those pictures we had when we were doing area where we had the square and then the circle that was inscribed in the square?
Oh, yeah.
Okay, I kind of missed right there, but you can see what I was trying to do, right? Okay, this is like the three-dimensional analog to that. Okay, so all of the tricks that we used back then where the diameter of our circle was also the height of our square, all of that's coming back into play. Do you guys remember all those fun little tricks? Yes, ma'am?
So since they have this, wait, would they have the same surface area, just not the same volume?
No. Nope.
Okay.
We're gonna find it right now. Okay, so keep that in mind.
How do I do like?
So we want to find the volume of the basketball. So they're telling us that the diameter is 10, but we need the radius. Now we can draw the radius here, or we can draw the radius, oops, I went too far. Here. Okay, now it's the same radius that's right here, right? Does everybody see that? It's for this circle. Right? Right? Okay. So let's do the volume of the basketball. So volume equals 4/3 pi times my radius, which is 5, because it's half of my diameter, cubed, which is
166.6 repeated.
It is not telling us that we get to round. So 5 cubed is what?
120.
125 times 4 is what?
500.
Is it?
Yeah.
So it's 500 divided by 3 pi, right? Inches cubed. Okay. How much space within the cylinder is not taken up by the ball? So in order to answer that, we need to find the volume of the cylinder. So the plan is that we are going to do the volume of the cylinder minus the volume of the sphere, and then we get the volume left. Everybody okay with that? If you're planning on retaking your 412 quiz, this problem will probably help you a lot, actually. Okay, so let's find the volume of the cylinder. Okay, so we're going to start with the base, the area of the base.
They have the same base, right?
Yep. Well, they have the same radius, right? We said that this radius would also be for like the circle that's here and down here. They're all the same radius everywhere. Okay, so pi r squared for the base. Radius is 5 times the height.
By 10.
Yeah, because it's 2 radii or 1 diameter. Okay. So 250 pi.
Yeah.
Okay.
You just subtract it.
Yeah. This is inches cubed. So we're doing 250 pi minus 500 divided by 3 pi. We might have to round at this point. What was it?
The 500 divided by 3
Uh-huh.
is 166.6.
Whoa. You can just put the whole thing in your calculator and do 1 at the bottom.
61.
Okay, so in my calculator, I'm doing 500 divided by 3 with a pi minus 250 with a pi. Oops, I got it backwards. Okay, so I'm getting 261. Can we say 0.8?
Yeah.
Okay. 261.8 inches cubed. Okay, so that, cool. Okay, if we wanted to make a new cylinder that can hold 2 basketballs, let's do our new improved cylinder. Okay, we want another basketball. Okay, that's bad. I'm going to pretend like I did a better job. Okay, half of my basketball's hanging out. All right, so what is this new height going to be? Another 10, so the whole new height would be what? Okay. 20 inches. Okay, and then how much space within the new cylinder would not be taken up by the basketballs?
You would double.
523.
Yeah, everything just gets doubled. Okay, you guys are too smart for this problem. It's fine. So whatever that times 2 is.
523 times 6.
Yep. Okay. Oops. Okay. Last one. Which 2-dimensional shape, when rotated about its flat side, would create a sphere? Yeah, a semicircle. Let's draw a picture. It's good for your brain. That picture was not good for anybody's brain. I want to apologize to everybody for that picture. I don't know that anyone is any smarter for me having drawn that picture. I'd like to also apologize to the people watching at home. They weren't even asked if they wanted to see that picture. They had to see that against their will. Okay, so semicircle. Okay. What is the cross section of a sphere?
Circle.
Is there another one?
Not really.
No. I mean, if you cut it, they're all circles.
I think so.
Yeah, that's just like trying to make you think of stupid.
I was just wondering.
Sometimes teachers
It's
do
circle, no.
It's circle. All right, we're done. Stick a fork in us, we're done.